Hello. We are continuing with HSC 2019 Mathematics Extension 1, question 14, part B, and third part of that section. So B, I. This question is asking us to show that alpha lies between x1 and x2. If you remember in the previous parts, we looked at the function f of x equal to x cubed minus kx squared minus 1, where k was greater than 0. Alpha is the only real root of this function or polynomial. So alpha is the only root for that polynomial. And then to have an approximation for this root alpha, we used Newton's method, and we started with k as our first guess. And then using Newton's method, we showed that the second approximation, when you start from k, will be k plus 1 on k squared. So that's the first guess. That is the second approximation based on this guess root using Newton's method. And alpha is the actual root of the function or polynomial. Now, what they are asking us is to prove that that actual root lies between those two approximations. To prove that, if you look at any function, say this is a function like y equal to g of x, and this is the actual root where the g of x, the function of g of x is 0. And if I want to show that this value lies between, say, this value x2 and this value x1, if I want to show that this, say, let's call it u. If I want to show that u lies between x1 and x2, I need to show that for f of x1, the value of the function is negative. So f of x1 is negative, and f of x2 is positive. Okay, so the function has gone from a negative value to a positive value. So that means that during this process, at some stage it has to be passing through 0. So the function is increasing, and at some stage it must be 0. So that way, by showing that f of x1 is negative and f of x2 is positive, I can show that u, which is the value for which f of u is 0, must lie between them, and that will result x1 and x2 are making an interval where u is located inside that. It could be other way around too. If my function was like that, then and this was u and this was x1 and this was x2, here it's other way around, so it's gone from positive to negative. Okay, so then here f of x1 is positive, f of x2 is negative. and still that means that u lies between x2 and x2. So it doesn't matter in which one of them it is positive and in which one of them it is negative. Alright, now let's have a look at this case. So x1 here is k, then f of x1 is k, so f of x1 equal to k is equal to, that's my f of x, I sub in k for that. So that becomes k cubed minus k times k squared minus 1, that gives me k cubed minus k cubed minus 1, this k cubed cancels out, becomes minus 1. So as you can see, this is negative. Now we do the same for x2. f of x2, and x2 is nothing but k plus 1 on k squared. So I'm trying to find f of k plus 1 on k squared. So again, sub in the original function for f of x. So wherever I have x, I need to replace it with k plus 1 on k squared. So that becomes cubed minus k times k plus 1 on k squared squared minus 1. That is f of x2. Now, because this was negative, we got to show that this is positive. To do that, we can expand and simplify, but probably it's a bit quicker if I factorize for k plus 1 on k squared, all squared, between this and that. So what I'm doing k plus 1 on k squared to the power of 2. From that you got only k plus 1 on k squared left, from that you got only k left, and this minus 1 stays outside. Now in this second bracket, k and minus k cancels out, so you get k plus 1 on k squared, and inside that you have 1 on k squared, because k and minus k cancel. Minus 1. Again, I can expand this and multiply by that. Yeah, probably have to do that. So k squared plus 2 times k times 1 on k squared, then plus 1 on k squared squared is 1 on k to the 4, and all of that is times by 1 on k squared minus 1. Now, if I multiply this by everything in the bracket, I get 1 on k squared times k squared just becomes 1. 1 on k squared and 1 on k squared, these two cancel out, so we end up with 2k here. And 1 on k squared times 1 on k to the 4 becomes 1 on k to the 6 minus 1. So that becomes 1 plus 2k plus 1 on k to the 6 minus 1. This 1 and minus 1 cancels out, becomes 2k plus 1 on k to the 6. But k was positive. So this is positive and this is positive. So 2k plus 1 on k to the 6 is positive. And that proves the point, because f of k was negative and f of k plus 1 on k squared is positive. Then we say as f of x1 is negative and f of x2 is positive, so alpha lies between x1 and x2. Okay, that is the solution for part B, I. Thank you for watching.